All right, so solving a linear equation with several occurrences of the variable, fractional forms with binomial numerators. All right, so with this, there's a few different ways to do this. So we're going to start with the most efficient way, but then we're going to show you other ways to do this. So if this first one doesn't make sense, there's going to be two more examples, and we're going to do it a couple other different ways. So, but whatever we're doing, the first thing that we do when we have fractions is we want everything to be a fraction, and then we're going to use the LCD. And the LCD is the least common denominator. And you look at all your denominators and find the smallest number that all of them go into. So it's going to be a bigger number generally. So 7, 5, and 1 all go into 35. So my LCD is 35. So one thing that we can do with this, I'm going to rewrite the problem over here. 3x plus 8 over 7 plus 3x minus 1 over 5 equals 3 over 1. Now, if we multiply absolutely everything by the lowest common denominator, and that is going to be the lowest common denominator over 1, we can see what happens. So this is going to be 35 over 1, 35 over 1. I'm going to put this stuff in parentheses because it's that whole fraction that's getting multiplied times 35 over 1. Now, I can reduce, when I'm multiplying fractions together, which is what I'm doing here, I can reduce anything from the top and bottom if they go into things, which is why I want these binomials as one thing, so I'm putting them in parentheses. So 7 goes into 35 5 times. This will become a 1. 5 goes into 35 7 times, so this becomes a 1. And then all of my denominators are 1, so I don't really need them. So my problem now looks like 5 times 3x plus 8 plus 7, 3x minus 1 equals 3 times 35. And now remember, because that denominator is 1, that's every number can be written as a fraction by putting it over 1, and that 1, we just don't need to see it, but it's technically still there. So now we're going to distribute and simplify and combine like terms, but we're going to distribute first. So 5 times 3x is 15x. 5 times 8 is 40. A positive 7 times 3x is 21x, and a 7 times negative 1 is negative 7. Now, I could have put them in a row, or I could have put them underneath each other, stack them if I wanted. Either way works. 35 times 3 is the same thing as 30 plus 5 times 3, which is 90 plus 15, which is 105. All right, so combining like terms, meaning anything with x's can go with anything with x's, anything that are whole numbers can go by with other whole numbers. So 15 plus 21 is 36x. 40 minus 7 is plus 33, and then I still have a 105 here. The goal with solving equations is to get the x completely by itself. So I need to get rid of all of the numbers on it. I'm going to do the opposite of the reverse of the order of operations. So I get rid of anything that is not directly touched to it. So get rid of anything added or subtracted. So minus 33. And then I have 36 equals 72. 36x, don't lose your letter. And then I'm going to divide by 36, and x equals 2. Save that, and then I'm going to type in my answer and hope my arithmetic is correct. Should be good. Yep. And then we are going to erase, and we are going to get our next problem, which in this case, I've got the 3y over minus 8. So I'm going to rewrite my problem. 3y minus 8 over 3. equals 15. I'm going to put that over 1 because I like everything to be a fraction. Minus 5y minus 4 over 6. Now, in this case, my LCD, it's always going to be bigger, but sometimes it can be the biggest number that I have. And in this case, my 3, 1, and 6 all go into 6. So my LCD is 6. So I'm going to make all of these, we'll do this a different way. In this case, I'm going to make all of my denominators become a 6. So to make a 3 a 6, I have to multiply it times 2. Whatever I do to the bottom, I have to do the top. To make 1 a 6, I'm going to have to multiply it by 6. Whatever I do to the bottom, I have to do the top. So this is going to make my equation 2. I'm going to just move my parentheses to be around the binomial instead. 2 times 3y minus 8 over 6 equals 15 times 6 over 6 minus, this one didn't need to change, 5y minus 4 over 6. Because I have a fraction, I do want parentheses around that last fraction, at least down around the top of it, just because subtraction means I have to subtract all of it. So I want to make sure that I'm remembering to subtract all of it. Now, I can simplify the tops. These two have the same denominator, so I can actually write the fraction as one fraction, but we're going to simplify the tops first. And we will change it to do this color. So distributing, we have 6y minus 16 over 6 equals 15 times 6 is 10 plus 5 times 6, which is 60, plus 30, which is 90. So 90 over 6 minus 5y. That's a messy 5y. We'll fix it. 5y minus 4 over 6. Now, what we remember with fractions is if the bottoms match, I can write them as one fraction. So this is going to be 6y minus 16 over 6 equals 90 minus 5y minus 4 over 6. Now, I do have to distribute. This minus could be a -1, or I'm thinking this is the subtracting of everything in this denominator, this numerator, meaning I'm going to change all of their signs. So I'm running out of room, so we're going to squeeze it all over here. So I have 6y minus 16 over 6 equals 90 minus 5y, and then the opposite of -4 is +4, all over 6. Now, when you have a fraction equals a fraction, the denominators are the same, so I could just solve the top. Or the only time I'm allowed to cross multiply is when I have a fraction over a fraction. I have not finished simplifying though. So I have 6y minus 16 over 6 equals 94 minus 5y over 6. And if I cross multiply, this is going to become 6 times 6y minus 16 equals 6 times 94 minus 5y. Now, both sides of that equation have a times 6. So rather than distributing, I'm going to divide both sides by 6 because that's the opposite of multiplying. This one cancels with this. This one cancels with this, and I have 6y minus 16 equals 94 plus 5y minus 5y. Got ahead of myself. Got not trust me with those minuses. Okay, so minus 5y. Now I'm going to get all the y's on one side, the x's on the other. I do this one thing at a time, but if you look at the work afterwards, it looks like I did it all at once. So I'm going to first get the y's together, and there's more over on the left. So I'm going to add 5 y's from this side. So I have 11y. These cancel out. And then I'm going to go plus 16 because on the side with the y, I need to get rid of anything else. So plus 16 equals 110. And now I get to finish solving this. So I'm going to divide both sides by 11. And you get y equals 10. Then we're going to type it in. Okay. And we're going to get 10. And then we're going to check it. We are good to go. So close that. And we're going to do our last one. We're kind of going to do a hybrid of it. We can get the common denominator, or we can multiply by the LCD. I think I'm going to actually multiply by the lowest common denominator because that will help you a lot more later on if you can get the hang of it. So this is going to be 9w. So 9w minus 1 over 4. I'm going to automatically just put that in parentheses, equals 3w minus 8 over 2 plus 6 over 1. So first thing I do is I want everything to be a fraction. My LCD is what number goes into, or what number do 4, 2, and 1 all go into, and they all go into 4. So in this case, I'm going to multiply everything by 4 because that is the fast way to do it, and it will help you in later things when we're dealing with algebraic fractions. So I'm going to multiply everything by the LCD over 1. And it works because I'm doing the absolute same thing to both sides of the equation and to every single term. I could call this as the distributing to everything that on the other side. But this works because I have an equal sign and I am doing the same thing to both sides of the equation. So once I have them written as I'm multiplying to them, I'm going to simplify my fractions, and this becomes a 1, this becomes a 1. So I really just have 9w minus 1. 2 goes into 2 once, 2 goes into 4 twice. So this equals 2 times 3w minus 8. And then these fractions, they're both over 1, so I'm just going to multiply across. So plus 24. Simplifying what I have, I'm going to distribute this to, let me rewrite this first, 9w minus 1 equals 2, no, equals 6. 2 times 3 is 6. All right, so I have 6w. 2 times negative 8 is minus 16 plus 24. Simplifying more of what I have, combining like terms. So negative 16 plus negative 24. That's the same thing as 24 minus 16. They're opposite signs, so I subtract them and I get 8. So 9w minus 1 equals 6w plus 8. Get the letters on one side, numbers on the other. I always move to start with the letters is what I like to do, just because I'm less likely to have to deal with negatives. There's more w's on the left, so I'm going to subtract 6w from both sides. This gives me 3w. And then I'm going to get rid of the stuff on the side with the 3w. So I'm going to add 1 to both sides. Equals, these cancel out. So I have 9. These cancel out. Divide both sides by the coefficient of w. So divide by 3. It is possible to get a fraction. However, in this case, we have all of 3 of these have been nice numbers. If they weren't, we would just write it as a fraction. So we're going to save my picture. We're going to type in my answer, which is 3, and hope we have our calculations correct. And we do.